Hello everyone. Today we're going to be talking about using recursive rules with sequences. So before, in previous lessons, we were working with the explicit rule, and that is a rule that gives an as a function of the term's position n in a sequence. So for example, for arithmetic, we had an is equal to 3n plus 7. And so if I were to plug 5 into there, I can find the fifth term of that sequence. Or for a geometric sequence, we had an is equal to 3 times 0.5 to the n power. A recursive rule, on the other hand, is a rule that gives the beginning terms of a sequence and a recursive equation that tells how an is related to one or more preceding terms. So for example, I could have a naught is equal to 3 and an is equal to an minus 1 plus 5. So this would be our first term, or that might instead be a1, just depending on the sequence. And you could read this an equals an minus 1 plus 5 as the term is equal to previous term plus 5. So for recursive rule, we have to know what the previous term is in order to find the next term. So let's go through some examples of using a recursive rule. So we're going to write the first 6 terms of each sequence. So number 1, I have a naught is equal to 1, and my rule that an is equal to an minus 1 plus 4. So that says my next term is equal to the previous plus 4. So first term is just a naught is equal to 1. A1 is going to equal to a1 minus 1, so a naught, plus 4. Well, a naught we found to be 1. So I'm going to substitute 1 in for a naught, and I get 1 plus 4, which is equal to 5. To find a2, I'm going to take the previous term, a1, and add 4. Well, the previous term is 5. Add 4 to that, and I get 9. I'm going to continue in that same fashion. So a3 is going to equal to the previous term, a2 plus 4. Well, the previous term we just found to be 9, so I'm going to get 9 plus 4, which is equal to 13. A4 is going to equal to the previous term plus 4, so A3 plus 4. Well, we just found that A3 is 13, so I'm going to have 13 plus 4 to get 17. And then my last term is going to be the previous A4 plus 4. So I have 17 plus 4, which is equal to 21. So the first 6 terms are going to be 1, 5, 9, 13, 17, and 21. So I see my first term is 1, and I'm adding 4 each time. Okay, let's try another one. So here I have f of 1 is equal to 1, and f of n is equal to 3 times f of n minus 1. So here, instead of having a 1, we're just writing it as a function of n. So my first term is going to be f of 1 is equal to 1. My next term, f of 2, is going to equal to 3 times my previous term, which is f of 1. Well, f of 1 we just saw is 1, so I have 3 times 1, which is equal to 3. F of 3 is going to equal to 3 times my previous term, which is f of 2. So I have 3 times f of 2, which we just found to be 3. And so I get 9. F of 4 is equal to 3 times my previous term, which is f of 3. So I have 3 times f of 3, which we just found to be 9. And I get 27. F of 5 is equal to 3 times my previous term, which is f of 4. which we just found to be 27. And I get 81. And then my last term, f of 6, is equal to 3 times my previous term, which is f of 5. So I have 3 times 81. And when I multiply that, I get 243. So my first 6 terms are 1, 3, 9, 27, 81, and 243. Now let's look at one more. So my first term is A1, so A1 is equal to 4. My next term, A2, is going to equal to 2 times my previous term, which is A1 minus 1. So I have 2 times 4 minus 1, which gets me 7. A3 is going to equal to 2 times my previous term, which is A2 minus 1. So I have 2 times 7 minus 1, which gets me 13. A4 is going to equal to 2 times my previous term, A3 minus 1, which is equal to 2 times 13 minus 1, which gets me 25. A5 is going to equal to 2 times my previous term, which is A4 minus 1. So I have 2 times 25 minus 1, which gets me 49. And then A6 is going to equal to 2 times my previous term, which is A5 minus 1. So I have 2 times 49 minus 1, which gets me 97. So the first 6 terms of this sequence are 4, 7, 13, 25, 49, and 97.